All right, guys, here we go. Let's see how this goes here today. This is a big lesson for you. Again, pause when you need to pause so you keep up with the notes. I'm going to go pretty quick and try to get this done as quickly as I can. 9.3 parallel lines and transversals. I can identify and evaluate parallel and transversal lines. We first need to understand what these two types of lines are. A parallel line would be two lines that will never intersect. Think railroad tracks. Railroad tracks are parallel lines. They are two lines. I'll give you an example that never intersect. So if we follow those two lines, like on the railroad tracks, they will never ever cross each other. Perpendicular lines would be two lines that intersect and form all right angles. So here's an example of perpendicular lines. Basically, you're making a plus. Okay, so we have two lines that intersect. When you have perpendicular lines, you're going to form a right angle, not only in this spot right here, but in this spot right here, in this spot right here, and this spot right here. All four angles make right angles. So if you have two intersecting lines and one of the angles is 90 degrees, you know that all four of them would be 90 degrees because you already know about vertical angles, opposite angles being congruent. Corresponding angles, probably the trickiest of all, would be angles that have the same measure and sit in similar positions. Okay, so we have a couple of examples of corresponding angles. We have two lines that are two parallel lines. So here's a parallel line along with this one. And then it is being cut by this line right here. They're both being cut by that line. And corresponding angles would be angles that have the same measure and sit in the same position. So we identified this spot right here and this spot right here. So in red here, and I just highlighted them in black, in red and black, and we have corresponding angles. They sit in the exact same position. They have the same measure. So if we look at this angle, it looks exactly like that angle. Those two angles are the same. We have some corresponding angles right below them. So this angle and this angle, which I'm highlighting in blue again, are corresponding. They sit in the exact same position. And if you trace them, they're going to form the exact same angle. And again, corresponding angles, they sit in a similar position and have the same angle measurement. Last word then is a transversal. Transversal is a line that intersects two or more lines. So up here, this is a transversal because it's crossing two lines. Right here, we're going to call the transversal line A. It is intersecting two lines or more. So that would be called a transversal. Last two words, I'm sorry I lied to you. Transversal wasn't the last word, but the 5 and 6 are quick and simple. Interior means inside. Exterior means outside. We'll come back to those words in a moment. In the cheat sheet, I do want you to write this down. There are some symbols for parallel, perpendicular. Parallel, the symbol is two straight lines going up and down. And perpendicular, I'm sorry, I'm not going to talk about symbols yet. Parallel would be two straight lines that never intersect. Perpendicular would be two intersecting lines that form all 90-degree angles. And then a transversal would be two lines, or a line that intersect at least two lines. So those are your vocab words. That's your cheat sheet. Ignore what I said about symbols. We'll get to that in a moment. Main idea number 2. When a transversal crosses parallel lines, special things happen. So here we go. Number 8. We have two parallel lines, line A and line B. You can see those on your screen. Line C is going to be our transversal. It crosses A and B. A and B again are parallel because I told you they were right here. Line A is parallel to line B. So again, line A is parallel to line B. This right here is the symbol for parallel. So the parallel symbol would be two straight lines. So that's what I was accidentally mentioning earlier. So line A is parallel to line B. And we have line C cutting across them. And because we have a transversal cutting across parallel lines, some special things start happening. Okay, so I'm going to erase the lines that I just drew, and we're going to talk about the special things that start happening down here on number 9. Some special things, we're going to stay on number 8. Some special things that happen would be that we have angles that are the exact same or corresponding. There's angles sitting in the same spot with the same measure. So I'm going to start with this right here. We have this angle and we have this angle. If you look like they're two acute angles. They're sitting in the exact same spot. This angle, the first one on top, is being intersected by a transversal is intersecting this line A. and the transversals intersecting this line B, they're corresponding angles because they sit in the exact same spot, just in a different location on that angle. Their angle measures are going to be the same, they're acute, and so on and so forth. So if you continue to look at this drawing, you can see that this angle right here, I'm going to use my angle markers as two reds, is going to be congruent to this angle right here. Again, those two angles sit in the exact same spot where the transversal cuts line A and cuts line B. And we could keep on going with this. This angle right here, I'm going to mark it with 3, is the exact same as this angle right there. They're sitting in the exact same location, which would mean corresponding locations. And then the last one, I'll grab my green. This angle right here, I'm going to mark it with 4 curvy lines. I'm going to mark this one with 4 curvy lines. Exact same angle measure, exact same angle, sitting in the exact same spot where the transversal cuts each of those parallel lines. Moving down to number 9. So now we're going to do some math with this. So number 9, we have parallel line A and parallel line B, and I'm going to tell you right now, A is parallel to B. Remember the symbol for parallel is 2 straight lines. T is your transversal, which you already know because it cuts across A and B. I have told you that this angle right here is 110 degrees. You know that if we look up here, we know that if we can find another angle in the exact same location on line B as what we have on line A, that one's also going to be 110 degrees. And check this out. We found a corresponding angle right here, and that's 110 degrees. You also know from earlier learning that opposite angles are called vertical angles and they're congruent. So you know that this is 110 degrees, and you know that this is 110 degrees. This is 110 degrees over here on your right because of vertical angles. It's also 110 degrees because this angle right here, the one I'm drawing on, is corresponds to that angle. They're the exact same angle sitting on different parallel lines being cut by the transversal. Okay? Now, if this is 110 degrees right there, this is my angle. Right here we have a straight line. So this straight line, line A, measures 180 degrees because all straight lines measure 180 degrees. So we know that whatever 180 minus 110 is, will give us this angle measurement, which is going to be 70. Okay? Corresponding angle over here, it looks acute. This one is acute, 70 degrees. Vertical angle, 70 degrees. Vertical angle, 70 degrees. Look what I did there. Because I knew this, 110, because I knew that A and B were parallel, and I saw the transversal T coming across my lines A and B that were parallel, I was able to find the rest of the other 7 angles. So these two right here go hand in hand. They work together. All right, I'm back. Sorry, I had to take a quick break there. I'm going to slide down to number 10, which is our last one. And we're going to talk about some other angles, or some wordings for some other angles. And we'll spend more time on this on Friday. But we're going to talk about alternate interior angles and alternate exterior angles. Pay attention here to what I'm talking about, and I think you'll be able to figure these out. Alternate means opposite sides, or every other. Interior means on the inside, and exterior means on the outside. So alternate interior angles, we have in our shape here, we have an A and a B. I'm going to tell you A is parallel to B. This is going to be your transversal, the one that crosses both of them. So we're going to call that T for transversal. And we have angles 1, 2, 3, 4, 5, 6, 7, 8. And we have interior angles. Interior angles would be angles that are on the inside of the parallel lines. So my interior angles would be these angles right here. They're on the inside of the parallel lines. My exterior angles would be angles on the outside of the parallel lines. So 1, 2, 7, 8 are my exteriors. 3, 4, 5, 6 are my interior angles. Okay, so I'm going to delete this so we have more room to work. Okay, so alternate interior angles. So let's just look at 3, 4, 5, and 6 because those are our interior angles. Angle 5, interior. Alternating the transversal would be angle 4. Angle 5 and angle 4 are alternate interior angles. And if you look at angle 5 and angle 4, they both look like they both are obtuse angles. So they are going to have similar angle measurements because alternate interior angles are congruent. Just like alternate exterior angles are congruent. So in other words, they have the same angle measure. So keeping with the theme of the interior angles, angle 3 and angle 6 are alternate interior angles. Angle 3 and angle 6, alternate interior angles. Angle 3 is forming an acute. Angle 6 is forming an acute. Alternate interior angles are congruent. Scrolling down, alternate exterior angles. Angle 1, angle 8. They're on the outside of the parallel lines. So angle 1 and angle 8 are alternating exterior angles. And again, do they look like they're congruent? Obtuse, obtuse, they sure do. And then if you haven't guessed it already, or if you haven't figured it out already, angle 2 and angle 7 are also alternate exterior angles. Angle 7 is acute, angle 2 is acute. Again, you know alternate exterior angles are congruent, alternate interior angles are congruent. Just another way of looking at angles and looking at congruency. I'm going to slide up here and just talk about interior and exterior angles again really quick. We have parallel line A, we have parallel line B. This 110 degree angle, which we already figured out, and this 110 degree angle are alternate interior angles because they're inside of A and B. And look at, they're equal 110 degrees. Okay, so just another way of figuring out what angles are equal to what, or another reason to apply why they are what they are as far as their measurements. 70 and 70, alternate interior angles are congruent the same. 70 and 70, alternate exterior angles, they're outside of the parallel lines A and B, and they're alternating the transversal. They're congruent. 110, 110, alternate exterior angles. We did not do, or we are not going to, or I'm not going to give you, sorry, a cheat sheet because I want you to come up with your own cheat sheet for number 2. Big things again here is we have parallel lines, transversals. When you have a parallel lines or a couple of parallel lines and a transversal, some really, really cool things happen. You can use number 8 to help you realize congruent angles. You can use number 9 to show some of the math. And then you can use number 10 to help you with the alternate interior and alternate exterior angles. Make sure your notes are taken well. Good luck, and you'll get your assignment on Schoology.